Hello, my name is Cary Jensen, and welcome to this Rad in Action webinar. Today's topic, Universal Enterprise Data Connectivity with FireDAC. Here are the major topics that I'm going to be covering today. I'm going to begin with an overview of FireDAC, including what it is and how it relates to other RAD Studio data access mechanisms. I'll also create a small application that demonstrates how easy it is to connect to your data using FireDAC. And then I'll talk about the FireDAC features that make it the preferred data access mechanism in RAD Studio going forward. I'll show many different examples of FireDAC's advanced features, and there will be a fair amount of code that we'll look at there. I'll also talk about how to migrate applications to FireDAC, either from an existing data access mechanism, or I'll also talk about how to create side-by-side deployments where you use FireDAC with some other existing data access mechanism. I'll complete the talk today with a look at 5 applications that use FireDAC across a wide range of environments. I'll show a simple client-server application, I'll show a distributed application that is based on DataSnap, and I'll also show a couple of the applications will be mobile applications, and one will use SQLite on the mobile device. Understanding FireDAC. FireDAC is a data access framework for RAD Studio. RAD Studio includes a number of different data access mechanisms, including dbGo, which is used for ActiveX data components, dbExpress for interbase, the Borland Database Engine, or BDE, dbExpress, and even the MyDB, which is based on the client dataset. Like those other data access frameworks, FireDAC represents the T-dataset interface. Specifically, there's a large number of capabilities introduced into the T-dataset class, and those capabilities are found in every one of the data access mechanisms in RAD Studio. The BDE was originally shipped with RAD Studio, and while at the time it was a rather advanced data access mechanism, it has fallen out of favor over the years. It is currently deprecated and has been deprecated for quite a few versions of RAD Studio. Some of the limitations of the BDE is it has a cumbersome installation, it uses a lot of network bandwidth and wasn't favored by IT departments, but it still is actually in use today, and I'm going to talk a little bit about that when I talk about migration to FireDAC applications, because especially if you're using the BDE, you will want to move off the BDE as soon as possible. The BDE has been deprecated for a while, and it's very likely that we'll see its removal from the product sometime in the near future, possibly as soon as the next version of RAD Studio. And of course, one of the reasons why you might see the BDE go away entirely is that FireDAC is an exceptionally good alternative. There's another alternative, in fact, the one that at the time Enterprise was championing as the migration path for the BDE, and that's dbExpress. Now, I mentioned that the BDE supports the T-dataset interface, and that interface is a primarily navigational interface where T-datasets have methods such as first, next, prior, last, edit, post. Many other methods and properties are involved in this interface, and it worked very well for the sequential access mechanism that was supported by the BDE. The BDE also supported SQL through the Borland SQL links for Windows, which was a set of drivers for specific SQL servers, and you use those drivers in connection with the BDE to access your SQL databases. The BDE has been deprecated, but Borland SQL links for Windows has been deprecated long before the BDE was deprecated. Back when Enterprise was developing Kylix, the Linux IDE and compiler for Delphi, they knew that they needed to come up with an alternative data access mechanism, and that access mechanism was dbExpress. dbExpress was primarily supported through pass-through SQL, and it was kind of a traditional set-based interface for working with data. Now, there's a couple problems with using dbExpress as your upgrade from the BDE, and the primary one is that dbExpress, while associated with the T-dataset interface, had unidirectional and read-only cursors, which means that a number of the methods of the T-dataset interface would raise exceptions if you use them. For example, you couldn't call edit on a dbExpress dataset, such as the SQL dataset. Doing so raised an exception. In fact, if you tried to take a SQL dataset that had loaded data and hook it up to one of the visual component libraries, or VCL's visual controls, it would raise an exception because it's not bi-directional. So dbExpress, just on the surface, while a T-dataset interface, lacked the support for many of the methods that were supported by the BDE. Another element of dbExpress, and one that was a direct outcome of its use of unidirectional and read-only cursors, is that the architecture was more complicated to implement. Specifically, in addition to your SQL connection and SQL dataset components for accessing data, you needed to bring the data into memory on the client, and Brad Studio includes the client dataset for that purpose. And while the client dataset is holding that data, it can be edited either programmatically or through user interface elements by an end user of your applications. And then all the changes that are made by your code or by the user are cached. Now that cache needs to be maintained. You need to apply it, and failure to apply those changes means that the user's changes or your programmatic changes would be lost. It's just that the architecture was much more complicated. With the BDE, all you needed to do was open a T-query or a T-table, and you could edit your data, and in many cases, both with queries and tables, as you modified your records, those records would be applied to the underlying database on a record-by-record basis. So it was a very simple user interface. You didn't have to worry about managing the cache. You didn't have to worry about having to apply changes in batch mode. And so the BDE supported the T-dataset interface, and dbExpress kind of supported it, but just migrating from the BDE to dbExpress was no simple matter. Yet another feature that made it a difficult migration was the dbExpress, at least in the many initial versions, had no support for some of the databases that people using the BDE were using. And I'm talking specifically about file server type databases. So if you were a user of paradox tables for a database, dbExpress wasn't an option, because you couldn't support it through there. You could easily argue, well, you know, the paradox file format is an old style format. It is not stable like the transaction supporting remote database server, so why don't you move your data from paradox to a SQL server and then you can use dbExpress? And you know, that's great if it's possible, and in a lot of cases it is possible, and probably most of the developers, most of you who have been using paradox tables in the past have made that migration. But it wasn't always possible. In some cases, your applications used paradox tables because there were other applications out there, some of which you had no control over, that used paradox tables or dbase tables or another file server based table format. In those cases, dbExpress wasn't an option. So let's talk about FireDAC. FireDAC comes along, and it has a couple features in its favor. Number one, it's a fantastic implementation of the T-dataset interface. Everything that you can do with the BDE is supported by FireDAC. So you can open up a table or a query. Actually, the FireDAC query is the preferred component for accessing your database. But you can open up a FireDAC query and then immediately enter the edit mode and programmatically change a record. You can hook up the FireDAC query to the user interface, either through the VCL or through FireMonkey components and live bindings. And there's nothing in the T-dataset interface that doesn't work well with FireDAC, so you don't have that limitation that dbExpress posed. In fact, if you examine the interfaces for the FireDAC datasets, you'll see that it goes well beyond T-dataset itself, implementing some of the best features of of components that have gone outside the T-dataset interface. For example, the T-client dataset has features that are not inherited from T-dataset but are nonetheless really nice. An example of that is aggregates. Another one is group state. Filtered navigation is yet another one that's really nice. And FireDAC supports all of those features. So if you're familiar with using the BDE, if you're familiar with using T-dataset, you already know how to use FireDAC, at least on its major features of data access. But FireDAC is not just like the BDE and then it's navigational. It is very, very SQL friendly. In fact, it internally is structured a lot like you find in frameworks like the .NET Dataset framework, where you have internal components that manage aspects of the execution. And especially with FireDAC, you have database drivers that talk very specifically to the databases they support and leverage their capabilities. But FireDAC does go beyond the T-dataset because it implements, for instance, those features I just mentioned with respect to client dataset. So it implements aggregates, it implements group state, it implements filtered navigation, but it goes even further than that. It has client-side indexes. So just like the client dataset has index field names, you can use index field names to create client-side indexes on your FireDAC datasets, and that is really a powerful thing. Furthermore, you have complex expressions that you can use in your filters and your locate statement. So FireDAC has a complete implementation of the T-data interface, and then it goes well beyond that. Before we go any further, I want you to be comfortable with FireDAC just out of the box, and so I'm going to create a simple application that connects the data and lets us edit data in the user interface. I will create this as a VCL application, but you'll see that many of my applications that I'll be using in today's webinar are also FireMonkey applications. So FireMonkey, VCL, all of it is supported with FireDAC through both the VCL's data awareness and live bindings. Now, in this case, I really do want to make this simple, and I'm currently in a virtual machine, and what I'm going to do is move over to a virtual machine that has Delphi XE5 Professional installed. And this is important that for you to understand that even if you're a RAD Studio professional developer, you do have access to FireDAC. Those specifically out of the box, the FireDAC version is designed for local access only, so things like Microsoft Access tables, Paradox tables, and the like. So I'm going to create a new application here, and like I said, I'm going to make it just a simple VCL Forms application. And on my form, I'll put a DB Navigator, I'll put a DB Grid, and we'll put, let's see here, DB Grid, and let's put a data source here as well. So we'll get our components wired up and set this here and this here. I'll take and I will anchor my DB Grid, and we'll hook up both the DB Grid and the Navigator to our data source. Now, like most of you will develop in your applications, I'm going to create a data module and put my data access components on there. This is not a requirement, but it's certainly a good idea and it's good practice. So what this does is it allows you to implement data access through a common shareable a module. So you might have one, you may have a collection of data modules, but in this case I have a data module here that I'll be using. So we make our connection in FireDAC using an FD connection component. The FD connection component represents a connection to the database, and it's one of many ways to connect to databases. What I'm going to do is I'm going to create what's referred to as a temporary connection here. And I will do this for the Microsoft Access driver. And I'm also touching Microsoft Access because it's one of the supported professional databases, and there's also a native driver in FireDAC for this database. The database that we're going to connect to is located in a directory that was installed when you installed RAD Studio. So I'm going to RAD Studio 12 samples data, and in there I'll find the dbdemos.mdb database to which I'm going to connect. Since we don't have any encryption on this database, I don't need a username or password. There's really nothing else I have to set up right now, so we are actually ready to go out and test. So I click the test button, I'll click OK in this login, and it tells me that I've established my connection successfully. Now this is the connection editor. And it has a number of other features that are pretty cool. One is that you can access the different options supported by FireDAC through this options tab of the connection editor. Formatting options, fetch options, update options, and resource options. And since this is a component editor, it gives us support to easily set these connections or connection options, and so we can go through and do this here. Alternatively, you'll notice these same options or the same properties appear in the Object Inspector. So we could do it manually in the Object Inspector, or we can get the assistance that the connection editor supplies. There's also an Info tab, and it gives you information about your connection, and this is particularly useful if you have some difficulty at some point connecting. You can see what drivers are being used. Specifically, it'll tell you what you're connecting to, and you'll see that in this case it's loading the ODBC 32-bit driver. Other information about everything that's going on is presented here, and this, as I said, can be quite useful. And finally, there's actually a page where you can do things like type in queries, select all from customer, probably the most commonly executed SQL statement in the world, and then we can actually look at our data and get a sense and test out queries right here if we wish. However, the most important thing is that when we selected our driver ID up here, the parameters that showed up in the side showed us or held our hand essentially for this particular native FireDAC driver to show us what properties are available and then assist us in setting those properties. When we accept and close the connection editor, what I want to show you is the settings that we set there are actually written to the params property of the FireDAC connection. This is also gives you a hint as how you can set some of your parameters and make your connection if you're doing it programmatically. All you really need to do is set the appropriate params name value pairs, and then you are going to be ready and be able to open your connection. So I can come up here and click on connected, and because I have login prompt set to true, it's asking for my credentials. I don't need any because it is a database that is not encrypted. In fact, what I'm going to do is turn off login prompt so I can activate my connection and not have to log in each time. We use the connection from one or more T data sets, and as I said, the FireDAC query is the data set of choice for most data access, and you'll see in a moment why I'm saying that. If we were talking about the old BDE days, most developers were using a T table, but the FireDAC query is kind of our go-to component here that we're going to use. Notice that when I hooked up to, or when I dropped the FireDAC query, it automatically hooked up to a connection that it found on this module, which is the FD connection 1. If you have multiple connections, you may have to assign which connection you want your particular T data set to hook up to. While there are many options available here, I'm just going to really focus on the major features, and so I'm going to go right to the SQL query and select my all from customer. Now at this point I could actually activate my query, and let me go ahead and save this temporarily. We'll save the project as. I'm going to go into, let's see, I'll just do it right here and say this is a MS Access FireDAC project. I'll save my data module as data module U. I'll save my main form as main form U, and I'll save my project as MS Access FireDAC. If I come over to my main form and use my data module unit, you'll see that I can then wire up my query to my data-aware controls. The DB Navigator automatically updates and kind of indicates that I'm on the very first record, that there's no records prior, and that I can navigate to these other records, and that they are not in an edit mode where I either intend to post or cancel that update. So we look like we're ready to go, but FireDAC requires just a little more tweaking, because if we run right now, we will get an error when it tries to load the project, and that is because it's missing some resources. So we come up and it's giving us this detailed description. It says the MS Access driver is not registered, and it's suggesting that there's a particular FireDAC component, the FDFizz MS Access driver link component, that will help us. Well, in reality, there's actually two components that we need. So I'm going to come in here and close this up and come back over to my data module and add the two components. One of these is found in the FireDAC links, and that's the access driver that it was talking about. So we come up here and we find our MS Access Fizz driver. That's the driver we need right there. And then there's another one actually that we're going to need, and it's associated with the user interface, and it's called the FD GUI Wait Cursor. Now, to be honest with you, you actually don't need these components. What you need are the units that they're going to add to your uses clause. So let's take a quick look at the uses clause here. And what I'm going to do now is compile, and what you're going to see, well, actually, let me just save. And when I hit the save button, I hit Control S, and these various components were added in here, or various units. These units represent the units that are associated with those controls, and they ensure, as long as those units appear in the uses clause, they ensure that the appropriate resources are registered when those units are initialized. So I could, at this point, actually take those components off of here, but there's really no need. But there is certainly no configuration that I need to perform here. So let me go ahead, hit run, and now we'll get our running application. And I'll come in and let's make a little bit of some changes to this data. I'll come in here and change Kawaii Dive Shop to a more modern spelling of the word shop, and I just posted that record, and that record was immediately written down to the underlying database. And you may notice that this was a query, but FireDAC is very intelligent about how it understands the relationship between the data in your queries and the underlying database, and in many cases it will be able to take that data and write it back to the underlying database. And all of these changes are being made on a line-by-line basis. So I'll type this here, post the change. Well, I can post the change just by moving off. I can insert a new record. No, I hit the wrong thing. Let me not delete, and I'll add a new record. I'll come in here and create a record number 9000, and we'll say some company, and I'll post that change, and these changes are now in the database. If I refresh my view, you'll see there's my new some company record, and I come up here in the Dive Shop and Site Diver Limited, have those changes that I made there. Let me go ahead and fix up the database to get it back to the way it was, just because I like to keep my data clean. Let's go in here and also change this back. Of course, these changes are being applied as I touch the data, and so this is effortless. There's very little we need to do except just put these components together, and we have a very functional application, similar to what you might have expected from the BDE, except we have a whole lot more features than I have shown you yet. So let's talk about those advanced features that I've been alluding to. We're going to go through a pretty good list of really nifty things that FireDAC can do, and for most of them I have examples, and so we're going to look at a fair amount of code in the next 20 or 30 minutes. The code samples are listed in this blue font that you see on my slides, and all of those examples are associated with the download associated with this webinar. So there's a white paper that's a rather significant paper that talks about everything that I'm covering here, and it also has all these different data examples, or these application examples. So some of them don't have examples, but I will sometimes go over to Delphi and kind of point some things out, and sometimes I'll just talk about it. So let's talk about the first one, and I don't need to say too much about it, other than FireDAC has complete cross-platform support for RAD Studio. FireDAC compiles for every single target compiler that is included in RAD Studio, and there are 6 compilers. There's the Win32 compiler, the Win64 compiler, the OSX compiler for Macintosh, the iOS compiler for iOS devices such as iPads and iPhones, the Android compiler, And that's 5 of them. What's the 6th one? Well, it's the iOS simulator compiler, which is not the same as the iOS compiler. So those are the 6 compilers. And FireDAC can be used in every one of those target platforms. And we're going to see some of that in the upcoming examples. The second point is that FireDAC has exceptional support for databases. It supports most of the major commercial databases and many of the major open source databases. So let's actually go over to Delphi here and get a sense of what that looks like. This is now I'm in RAD Studio Enterprise, and I'm just going to create a form just so that if I want to throw some components down, I can, but I want to show you that if we look at the links, we can see that there's an Oracle driver, there's a DB2 driver, a Microsoft SQL Server driver, a DataSnap driver, a dbExpress driver, which is also a DataSnap driver. Some of these are not for specifically databases. I'll talk about the monitor in a little bit. There's an ODBC driver. That's actually a bridging driver. The MS Access driver, however, is a native driver. There's a MySQL driver, the a SQL Anywhere driver, an Advantage Database Server driver, a Firebird driver, Progress SQL, Interbase driver, there's a SQLite driver. So their drivers can be divided into 2 categories. We have our native drivers like the Oracle driver and DB2 and Interbase and Microsoft SQL Server. And then there's some bridging drivers, and the bridging drivers are the ODBC driver and the 2 DataSnap related drivers. The native drivers have intimate knowledge of those particular interfaces, and the bridging drivers are using kind of an open standard for communication. The DataSnap drivers being very Embarcadero centric, and ODBC being a widely supported database standard for accessing data. Going back to our slides, we have exceptional support for databases. Now here's the next, another feature, flexible queries through dynamic SQL. Dynamic SQL is the process by which FireDAC can pre-process your SQL statements and perform a number of manipulations on those SQL statements. For instance, you can embed variables in your SQL statements and then assign those variables at runtime or even design time before the query is executed, and those variables will be substituted for the values that you have assigned to the variables. Let's take a look at this one. This is a relatively simple application, but nonetheless it is will give you some sense of the power of using variable substitution in portions of a query that are where you could not use parameters. So this is kind of one of the ideas. For instance, you can't define the table in a from statement using a parameter. That's just not possible. But what you could do is you could use variable substitution. So I'm going to show you actually a query that I have that uses variable substitution. So this is a FireDAC query, and what I'm saying here is select all from at table, and selecting all from at table, that at, or the ampersand sign, that's, excuse me, the ampersand sign is a macro. I'm sorry, it's a variable. And what I've done here is I've actually applied a value at design time, but at runtime I'm actually going to pick the value based on something that someone selects. Actually, let's look how this works, and then we'll go look at the actual where variable substitution comes in. I wanted to create a little interface where user could just come up, select a table, select some fields, and then say, show me that data. And so this is all very dynamic. This is by the way, this is a FireMonkey application. We could select another table and say we want to see capital and continent. And let's customer, let's say we just want to see company and city and state. And so we're pulling out that data dynamically. Now, if we go back to the data module, this is the query we were executing there, and there are actually 2 variables here, at field list and at table name. And if we look at the button that says show data, we'll see that I'm calling load data here, and what it's doing is it's assigning data to those 2 variables through the macros property of the data set. And so one is I construct a field list, and another I select the table that was chosen. So there's an example of variable substitution. I have another example, and that is found in the macros example. This is a simple example, but it shows a little more involved set of capabilities in the macros. So let's go ahead and open up that. So FireDAC macros, and this is, I have everything on just one page here, but what I'm going to do is bring up the query editor for the FireDAC query and show you my SQL statement. Let's get a little bit of formatting here. So in this case, I'm using the current date. Let's put this in Notepad so we can see it a little easier. This will make it a lot nicer to look at. So we have in the curly braces, current date is a FireDAC function, and it's a date function. So the curly braces is telling the preprocessor, hey, here's a FireDAC thing to execute. Notice here I've got the variable substitution, and here's yet another FireDAC function, extract. Now what's important about these functions is that they're going to produce results that are formatted correctly for the specific database that we're connected to. Here's another one in which this is a constant macro expansion where I can specifically say this is a number and take that number and represent it in the form that this particular database that we're connecting to is going to need in order for it to be properly formatted SQL. So that just tells you one of the big things about dynamic SQL that's so cool is that what it does let you do is avoid the problems associated with idiosyncrasies in the actual data sets. Here, let me go ahead and open this. Boom. And we can avoid the idiosyncrasies of database-specific SQL. Other things we can do are conditional SQL. So dynamic SQL is a very, very cool and powerful capability of FireDAC. Cached updates are a mechanism similar to what the client dataset offers in that the changes you make to your data are cached. Now, this is a really big topic, and for those of you who saw my Code Rage 8 presentation, I talked extensively about cached updates with FireDAC. So I'm not going to go over that again other than to say on the code disk you'll find the cached updates example, and it demonstrates cached updates. So let's go over to Delphi. Oops. Let's go over to Delphi and at least bring that project up. So FireDAC and basic cache. Here's the cached updates example. So I'll just give you a little sense of this. When cached updates are enabled for FireDAC datasets, then we can do things like edit, delete, insert, and so forth, and those changes are not applied immediately. In fact, what they are is they are cached, and then we can apply the updates, we can cancel the updates, we can revert individual records. So I can come back here and say revert record, and is now unmodified, but this one is still modified. Let's cancel all updates, and now nothing's modified in there. If I had deleted records, they're undeleted. So there's a lot to this example, so I'm not going to cover any more of it right now. I'll come back to it in a second, but cached updates is a major feature that allows you to perform advanced operations on your data sets. Another capability in FireDAC datasets is result set persistence. Essentially, like you can do with the client dataset, you can say saved a file or saved a stream to store the contents of the dataset. This can also be used to store the cached the change log if you were in cached updates mode at the time that you said saved a file. My cached updates project actually demonstrates this, so that we can say, okay, here we have, let me go ahead and make a change into the cache, modified record. Now I'm going to say saved a file. It's saved to a file. Now I'm going to close my query. I'm going to disable cached updates on my dataset, but now I'm going to load from file, and we are actually in a cached mode. Notice that this is modified, and that is because those records are were saved in their form, and it has both the actual data and the change log as well. You save, just like with the client dataset, there are several different formats that you can save as. There is an XML format that's very similar to client dataset, but it's not identical. There's also a binary format, and there's some other format as well. I can't remember off the top of my head. what it is. But that's a very significant feature, because what it does let you do is it allows you to have disconnected applications very conveniently without having to employ some other type of data set, such as a FireDAC mem table or a client data set. Another great feature in FireDAC is ArrayDML. ArrayDML is a mechanism by which you can repeatedly execute a parameterized query or a parameterized stored procedure, and do so in a highly efficient manner. Let's go look at my code sample that has ArrayDML in it. So, OK. Now in this application, let me show you what it's doing, and then I'll describe how it's doing it. Okay, I have a table name that I can define. I'm going to create that table on the fly. I have a range of dates, and I'm going to create one record for every date in that range. So this is going to be about 2,000 records, and I'll create that. And okay, I need to pick a table name that doesn't exist, so let's do data table 99 and try that again, and bingo, we have our data. So ArrayDML leverages the capability of many servers, and then it emulates in the other servers the capability to pass not only a SQL statement but also an array of parameters. Now the way this works here is after we create the table, I'm creating a parameterized insert statement in this case. Then I'm figuring out the total number of days that are in the range that was provided, and I'm setting the array size of the params property. For each element of that params property that has an array, there's an array of arrays with one element for each of the parameters. So what I do is then I populate, before executing that query, I populate all the arrays of arrays in that params property. Finally, when I execute the query, I can tell it how many elements of the array to use, and it passes the array of arrays and the parameterized query to the server and lets it perform the updates there. In some cases, this produces absolutely blinding performance. Now, you might think, when would I need to use something like this? Well, in ETL, extract, transform, and load applications, you're often doing a tremendous amount of data manipulation. And this is exactly what you can do with ArrayDML very easily and conveniently and with super high performance in most cases. So it's a feature of FireDAC, and one that in many cases, this is especially useful in data warehousing, for instance, that you might need to do this type of thing. Okay, support for multi-threading and asynchronous queries. If you've ever done multi-threaded computing with databases, you know that you typically have to create a separate connection for every one of your threads, so that each thread is seen as a different user, and then that will resolve conflict for record level access in the queries and the transactions that you're executing against your database. Well, FireDAC does two things. One is, if you take that approach that I just described, and I'll show you an example of it, you have fully thread-safe type execution. However, there's a couple of execution modes that FireDAC supports that will actually manage the threads for you. Specifically, you can set up the command exec mode to be AM async, and what will happen is it'll execute the query in a thread that it creates and then destroys once the result set has returned. Of course, this requires that you have some kind of mechanism that will respond to when the query is done, and you typically do that from an after open event handler for the T data set. In addition, there's also the ability to, especially for queries that are going to take a little time, there's a cancel dialog mode where you can say, okay, execute this query, but show my user a dialog box that gives them a sense that the query is running, and that if they need to cancel the query before it's completed, they can interact with that dialog box. So FireDAC does this all for you. I have a project, of course, that we'll look at here that demonstrates this. This project is called thread execute. And I've demonstrated all the different examples. So the typical default blocking is called execute with blocking. And what happens is the calling code, which is the primary thread of execution in this particular case, is blocked until the query returns. And that's typically what we expect. We call open, and when open returns, the query is done, and so forth. I also have other examples here, executing asynchronously from the primary thread of execution. And then this one here, which is interesting, in which I actually have a thread class that I've created. And this demonstrates the typical way that you take whole control of your threads. Now, before I get into that, I do want to show you that I have a data module here, because there's a component that I've only used in this particular application, and it's called the FD Manager. If we go to the onCreate of this data module, you'll see that I'm actually configuring the FD Manager, and what this does is it creates something called a persistent connection. And that connection, well, it's not persistent because I haven't actually saved it to an external file, so this is actually a private connection. But what I've done here is I've defined connection parameters in the FD Manager, including the fact that I want to use pooled connections, and I've given it a name. Now, over from my thread, when I create my connection object, what I do is I point it to that connection name, connection definition name, and it'll absorb the parameters, so that when I do finally open that connection, I'll be using those parameters. And in this case, it'll be from pooled connections, which is an optimization, since making a connection to a database is a moderately expensive proposition. And in some databases, it's a very expensive proposition. So, by the way, I noticed the login prompt I set the false here, but that's not necessary if you're calling open from a worker thread. FireDAC can detect that. So, in any case, what we're doing here is we're hooking up our connection and our query, and we're pulling in a mem table that's passed into us. We're opening the connection, opening the query, and making sure that we fetch all records. And through a call to synchronize, we're cloning the mem table that was passed into us, and then that is hooked up to the through our code here. It is hooked up right here on the after open. Oh, here we go. Here it's hooked up to the bind source DB of this interface. So let's go ahead and run this and see our threads executing in the background. First thing we'll do here is execute a blocking query. Here's a non-blocking query from the primary thread of execution, and I had to deal with that by responding in after open event handler. However, FireDAC will only support one asynchronous query at a time, whether we're calling it, we're executing asynchronously using the AM async functionality or the AM non-blocking functionality. However, when we execute in a thread the way that I showed you, we can execute as many queries at the same time and as many connections at the same time. And I have these all here. I can just pound away at this, and each one of the threads that are concurrently executing their data are taking care of business the way that I implemented in that thread. Yet another feature of FireDAC is its powerful monitoring capabilities. Using the monitor, we can inspect the SQL or subsets of the SQL that FireDAC is communicating to the underlying database. We can also do some relatively simple data dumps. We can dump the current record. We can even dump an entire database. We can also monitor characteristics of custom objects, but I'm going to really just focus here on the monitoring of the SQL statements. So what we do is we need to start up our monitor before we begin running our project, and the monitor is found in Program Files, Embarcadero, Rad Studio 12, and then the bin directory of Rad Studio. So come down here, and here's the FireDAC monitor. So got that running, and now let's go into Delphi here, and we'll pick up the Remote Monitor FMX project, another FireMonkey project. Let's go ahead and run this. I'm going to run it without debugging. And that had nothing to do with anything. It really wasn't necessary for me to do it that way. But we can see that the monitor is already picking up communications. So I could come in here and make some edits. And when I move off that record, the monitor updates, and we can see the various operations that were performed in order to communicate that edit with the underlying database. So this is a very powerful application. You can use the monitor since it's communicating using TCP/IP. You could monitor any application that's visible within your network or across the internet. You can also monitor multiple applications simultaneously. There's a lot of support for dialog boxes, and I'm going to, I got a couple examples. The Interbase Client Server application that I'll show at the end in the FireDAC in action. It has a dialog box that comes up, and it's a login dialog box. The cancel dialog for asynchronous that's supported by the queries. I talked about having a cancel dialog box come up. There's some error dialog box. There are other types of dialog boxes that are supported by FireDAC. In some cases, they just automatically show up. In other cases, you hook up, like for instance, your FD connection to the login dialog box instance that you're going to use, and then it will invoke that dialog box and then manage the user's connection to the database through that, and you don't have to build your own login dialog box, and it just makes everything straightforward. Now, another feature, and this is the one that's really one of the very coolest, is called local SQL. FireDAC supports execution of SQL statements against T datasets. So that isn't just FireDAC datasets, that's any dataset. So I have a simple little example here that I'm going to show. And in fact, let me go over just to show this, in fact, in my professional installation. This form, once the underlying dataset is activated, is going to show a query that performs a join between a FireDAC query that uses the Microsoft Access database and a traditional client dataset. And that's all found over on this data module. So the way this works, and it's a pretty clever sleight of hand here, is that you use a SQLite connection, and all it's doing is just saying, let's use the SQLite engine, and we need to have the SQLite driver link available for the same reason that we needed the Microsoft Access driver link to connect to Access. And then we have this component called local SQL, which basically acts as the glue between the various data sets that we're going to query against. So here's the employees table, the orders table, and if we look at the, let me actually go over here to my default layout. If we select any one of these, we'll see that there's a data set and an optional name. If we supply the name, we can use that name as the essentially alias in our query. Otherwise, we just use the component name of the various data sets that are in this list. Here we have our a local query component that is also using the SQLite connection, but it will define the query between those aliases that we defined here. So notice we have the orders table, we have the employees table, and I'm doing an inner join on the employees table. I'm doing a little bit of concatenation, plus we're selecting all the records from the O alias on the orders table. And when this is done, it'll connect the various tables and perform that join. Here, the employee table is pointing out to the employee XML database. However, I also have an on create event handler that is wiring up our data to the various places. It's hooking up the access connection properly. It's hooking up the client data set to the appropriate XML file. But the fun part of this is then when we're all done, we're running this application, we're working with data that is the product of a join between data sets. Now in this example, I've just joined two data sets, but there's really no limit. And you can do, you basically have access to almost the entire body of SQL or syntax of SQL that's supported by the SQLite engine. So you can do inserts, you can do updates, certainly joins and subqueries. You have a lot of power here. And this would be very interesting to use for performing aggregate calculations, for instance, on data that you have in your database so that you load your data data into memory once, and then rather than making round trips to your server for aggregate calculations, such as sum and averages or counts, you could simply do it on the data that's in memory. Either through your FD queries, or if you're using a FireDAC mem table as well, that would be a possibility. So those were the major features, but there's a lot more to FireDAC than I showed you there. So like the pitchman on TV says, but wait, there's more. So I'm not going to show you examples of each of them. I'm just going to talk about them so we can get on to the next topic, which is migration. So transparent connection recovery is a default default setting, but you can turn it off if you want. But what it does is that if you're in an unstable network environment and you are liable to lose your connection to the database, if the connection is dropped, FireDAC will attempt to reconnect. FireDAC also supports some of the specific services provided by some of the database implementations that it has drivers for. For instance, many of the databases have backup and recovery services, and FireDAC supplies components that easily allow you to use those services from within your applications. Data access in FireDAC is highly customizable. You have properties that allow you to fine-tune data access down to some very, very detailed levels. And this allows you to accommodate situations that are out of the ordinary that otherwise might require significant additions of code in order to accomplish. With FireDAC, the properties are surfaced on your connections and your individual data sets, and then at the higher level, the FireDAC manager, and this is essentially you inherit these characteristics. So you could set up some customization at the high level of FireDAC manager, and that'll be inherited by any FireDAC connection that gets used, which in turn is inherited by the individual FireDAC data sets that use those connections. We looked at, when we were first setting up the connection editor, I took you over and we saw some of those resource options, format options, fetch options, and that's what I'm talking about. Most of the time, the default settings are exactly what you want and they work fine. However, when they're not enough, you have the capability of going in and customizing to a very fine level how data is accessed. FireDAC supports data type mapping. So let's say that you're bringing data from, let's say that your database or your application supports multiple databases, but there's some incompatibilities in the data types of some of their fields. You can create data mappings for your databases so that depending on which database you're pulling from or communicating to, you are bringing and interacting with them in the client application in a common format that so that you don't have to have a lot of, again, customization that would probably be programmatic and rather complicated. FireDAC supports the concept of a virtual database driver, and essentially what a virtual database driver is one of FireDAC's existing database drivers pointing to a particular database and having a collection of parameters that define specifics of that data access, and then saving that information into a configuration definition file. When you use the name in that connection definition configuration file, you're essentially using your customized database driver. So it allows you to have a lot of control over the or easily reuse a customized set of parameters for connecting to data. And then finally, FireDAC is written entirely in Delphi. And that's a very significant thing. So there are other characteristics, but I've really highlighted the really main items. And I think you see now that FireDAC is really something special. This is a new era for RAD Studio, and all of this is why FireDAC is the data access framework of choice now for Delphi developers and RAD Studio developers. Now that you've seen what FireDAC can do for you, you're going to want to start using it. The easiest way is to, when you start new applications, is to use the FireDAC components, and you've seen how easy they are to place and configure. However, if you have advanced needs, they are highly customizable, and in a lot of cases, you're not going to have to write a lot of code to do to accommodate special case conditions, you can simply use the FireDAC properties in order to achieve the customizations that are necessary. But how about your existing applications? I want to point you to the white paper associated with this webinar for the details, but there are 4 different types of migrations you're likely to do. Before I just preview these, let me say a couple words about migration in general. The ease with which you migrate your applications is going to be assisted to the extent that you've isolated data access to just a few units or a few data modules. If you've approached development that way, you're reusing data modules or reusing units extensively, and you can focus your migration efforts on those few isolated units. If you've placed data access components on every form or frame in your application, it's going to be a much bigger challenge. So let me just go through real quickly here. FireDAC XE4 applications, those need to be migrated to XE5 because the names of the classes and the names of the units have changed. Fortunately, it's basically a one-to-one conversion, and XE5 FireDAC has essentially 100% backwards compatibility to earlier versions, so the migration is a simple one. There is an example script that performs a regular expression replacement of old class names with new class names, and that is described in the doc wiki. It's also described in the white paper associated with this seminar. If those scripts won't work for you, you can do a manual replacement, and I detail how that manual replacement is done in the white paper. If you have existing applications that use some other data access mechanism, if you find that that existing data access mechanism is not sufficient for your needs, you may want to do a complete conversion to FireDAC. Again, I talk about how that's done in the white paper. It's actually a little bit easier than the XE4 to XE5 FireDAC conversion because you actually can have your existing data access framework components and the FireDAC components exist simultaneously on your forms, which allows you to really make sure that you're configuring your new FireDAC components correctly before you remove the old components. If FireDAC doesn't supply a native driver for your application, you're going to, and you need to migrate it, you're going to need to use an ODBC driver. Now there's one particular situation where this happens a lot in FireDAC migration, and that is migrating BDE applications to use FireDAC, especially when your applications make use of paradox tables and must continue to use paradox tables. Now, if you don't have to use paradox tables, your better choice is to migrate your paradox tables to some other database, and hopefully a database that supports transactions and is a remote database server, because you get a much more stable environment. FireDAC has a number of classes that can assist, including the FD move data component that can point to an existing data set and then pump that data over into a FireDAC data set, so you could actually transfer, for instance, from paradox tables to Interbase or one of the other supported databases. However, if you have to continue using paradox tables, you want to get off the BDE and go to FireDAC. Let me go over to my XE5 Professional install and demonstrate an example of this. So I have an application that uses the paradox tables that ship with Rad Studio in the samples directory, and I have a data module here. And my FD connection, you'll see it's not a very complicated setup. I tell FireDAC that it's going to use its ODBC driver, and then I set the ODBC driver parameter of this driver to point to the ODBC driver that's installed in Windows. Then I use the ODBC advanced property to specify the specifics of my connection, including the location of the database. The DBQ points to the directory that the paradox tables are stored in, and you may also want to define a default directory as well. But that's all done with these parameters in the ODBC advanced property. Now you may recall that when you configure using the connection editor, it sets up params. Well, my code here demonstrates that as well, but instead of doing it at design time, I can do it at runtime and load in information, including I can dynamically calculate where that data is. So if we run this application, what we'll see is that when it starts up, it's connected using ODBC. These are paradox tables. There is really nothing different about how I approach my development here using FireDAC versus the old BDE. The important thing is that I get the BDE out of there because, as we know, it's not only been deprecated, but it's going to be gone one of these days, and this is makes this a good time to perform your migration. I have another example that's described in the white paper and is available at the code download that shows how to dynamically create a system ODBC data source name, but it's not necessary if you use this dynamic version that I just showed you. The last migration topic is side-by-side migration. This is appropriate if you have an existing database application and your data access framework is working fine. Now, you may eventually want to change over to all FireDAC in order to take advantage of FireDAC's features or future features that are implemented in FireDAC. But in the meantime, you can add FireDAC components and use them in conjunction with another existing database. For instance, I showed you local SQL. You can add FireDAC components to an existing application and then perform queries against your other data access data sets. And that's a very cool feature. Furthermore, you may want to start using the FireDAC mem table in your applications, and that can be used with non-FireDAC data sets as well. So this allows you to get some FireDAC features into your current applications without taking the time to completely replace your data access framework. And then later in the future, you may decide to replace the data access framework, but in the meantime, you'll get the features of FireDAC in your applications. This brings us to the last section in this presentation that I call FireDAC in action. There are 5 FireDAC applications that I'm going to showcase, and there's 2 principal points that I'm making here. Number 1, FireDAC can be used in a wide variety of application styles, including standalone applications, client-server applications, distributed applications, and mobile applications. The second point is that I can compile to multiple platforms using a common code base. So let's just get right to it. The very first application is an interbase application. This application is very similar to the Microsoft Access application I created earlier when demonstrating connecting to a database. The difference here is I'm connecting to interbase, which means I need the interbase physical link driver. Also, what you'll see here is that I am leaving a login prompt set to true, and I'm using one of the provided dialog boxes in FireDAC, the login dialog box. What's somewhat impressive about this particular application is that it's a fully functioning, working client-server application, but there is only one event handler in the whole application. Right here on the data module, in its onCreate event handler, I wire up to the interbase driver, I define the query I'm going to execute, and I open it. There is no other code on the remainder of the application. So let's go ahead and run it. This demonstrates just how easy it is to use FireDAC. By the way, the password for the sample DB Demos database is master key, all lowercase, no spaces. And I enter that in, and there's my application, and I can come in here. I can edit my data. Records are being posted on a record-by-record basis. Certainly, I can add so many of FireDAC's advanced features, such as cached updates and the like, but this demonstrates how simple it is to create a true client-server application using FireDAC. It's like the old BDE applications, but we're using a much, much more sophisticated and powerful data access framework with FireDAC. The next 3 applications are associated with DataSnap. I have a DataSnap server that uses FireDAC, and I have 2 DataSnap clients, one that is a Windows client and one that is a mobile client. Okay, here's the server. This server was designed as a VCL forms application. In reality, after I have debugged the server and made sure that everything is working appropriately, I would actually convert it to an ISAPI DLL using Web Broker. There's actually quite a lot of different options I have for server development. This is the one I'm using. Let me go ahead and get this one running, and I'm going to run this without debugging so that I have my server available for the two clients. So let's get it started. This is using HTTP and it's listing on port 8080. My components that I'm using here are in my server methods unit, and I've just made a rather simple DBX server where I'm exposing a FireDAC data through a dataset provider. So I have a FireDAC connection, a query that points to that FireDAC connection, then a dataset provider that points to that query. And this will allow me to supply the data for this dataset to a client DataSnap or DataSnap clients, and I can do so in such a way that the clients can modify the data and then post that data back to the DataSnap server. And that's kind of the key element here. The next project in this project group is a Windows DataSnap client. This DataSnap client has a data module in which we have a SQL connection that uses the ODBC or the dbExpress DataSnap driver. I have a DS provider connection and a client dataset that'll obtain the dataset from the DataSnap server through this connection. The main form of this project is shown here. It's a FireMonkey project, and when I click on this connect button, I hook up to the I hook the SQL connection up to the DataSnap server and open the client dataset. Then I have some code that allows me to apply updates if I make changes and cancel updates and so forth. So let me go ahead and run this application against our server. Okay, localhost, since the server and the client are both running here on the same machine, I'll say connect. I obtain my data from the DataSnap server. I can go in and make changes to this data. Once I have applied those changes, the apply updates and cancel updates buttons become enabled, and I can click on apply updates, and I have pushed that data back to the DataSnap server. DataSnap allows me to build clients for a wide range of environments or types of applications, a wide range of client types, and be able to access data through the common server. And I've used this particular approach because it allows me to very easily create read-write clients on nearly any platform. And I'll demonstrate that by showing you this next DataSnap client. This DataSnap client is a mobile application. This one is specifically set up for Android. And I have set up my target for this to be an Android device that I have connected via USB here. And I have previously gone ahead and I have compiled and deployed that application. So rather than starting over from scratch, let me go over here and view the application. And now I'm going to be using the tablet. Okay, so let's go over to my applications, and here we have this mobile DataSnap client. This was, as I said, previously deployed. Now what I need to do is type in the IP address for my DataSnap server, and this doesn't, the only essential part here is that my tablet be hooked up to the same network, and in other words that the DataSnap server is reachable from the tablet. So the USB cable that I've got connected here, that really is not a crucial thing. So okay, what I'm going to do is put in the IP address for my server. Okay, and now we'll hit connect. And there's our data, and we can edit this data as well. This application works just the same way as the Windows client that we saw a moment ago. Now I want to point out something that's very, very interesting about this particular application. This application, this DataSnap mobile client, uses the same data module that this one does. It's exactly the same data module. So that shows that I have taken the same data module with its components and I have compiled it for two different platforms. The other aspect is if we were to look at the form itself and you were to examine the event handlers on this form, you would see that they were identical to the event handlers on this form. I could even abstracted this code out so that both forms would use a common unit with these event handlers. I didn't do that. It's just the same exact code. My final project is a FireDAC client that uses the SQLite database on the mobile platform. So let's go back over to VNC Viewer and let me go to that application. I have previously deployed it. Now I'm not going to deploy it again right now because when it actually is first created, it builds a database using SQLite so long as the files don't already exist. And see, I can come in here and I'll go over and add a new phone number type. Let's say this is a cell number. And we'll come down and say that we are going to put in a number, and I'll just put in some silly number. If I can type on my tablet. Okay, so go ahead and add that, and there I have two different cell phone numbers for that entity. And again, we can go to the different, so this is a one-to-many view on this database. I will say that one reason why I didn't want to redeploy it right then is that when you redeploy, since I put the database into the user documents folder on the tablet, Rad Studio is actually going to uninstall that database as well. So I just want to mention that because it kind of caught me off guard the first couple of times. I said, where's my database go when I built it the first time I touched it? Well, you might want to take some steps to actually back up the database if you've got significant data on it before redeploy if it's part of the deployment itself. And so, any case, so there is a SQL client. Now, I do want to make a comment about the mobile client applications. They're using a very easy to build interface, but it's not very friendly as far as tablet goes. But that's not the point I'm trying to make. The point I'm making is that FireDAC is usable within a wide range of application types. And also we can use common code bases and share them amongst different target environments. So I can use the same code base. I can compile it for Windows. I can compile it for Macintosh. I can compile it for Android. I can compile it for iOS. And it's all supported. So I want to acknowledge the many people who helped with this webinar and the white paper. Particularly, I want to thank Dimitri, who is the FireDAC architect. He acted as technical editor on the white paper and provided technical support. I want to thank Tim Del Chiaro and Loy Anderson for reviewing the white paper. Steve Haney is the project manager, and then I received help, guidance, support, and all sorts of stuff like that from David I, JT, or John Thomas, Marco Cantu, Jason Volks, Jim McKeith, and Tim Del Chiaro. Thank you for joining me in this webinar today. The website for this webinar is www.embarcadero.com/radinaction/FireDAC. There you'll find this video, the white paper, and the sample applications that I have demonstrated in this webinar today. You can contact me at cjensen@jensendatasystems.com. My website is www.jensendatasystems.com. You can find my blog at caryjensen.blogspot.com, and my Twitter feed is at twitter.com/caryjensen. In addition to being a developer, consultant, trainer, and book author, I do regular tours, annual tours with Bob Swart on Delphi Developer Days. We are currently preparing for our spring tour for 2014, but we also have a special event in December in London. On December 4th and 5th, we'll have our traditional Delphi Developer Days 2-day seminar, where Bob and I both present sessions together as well as separately. If you attend that seminar, you receive the Delphi Developer Days coursebook, which which is over 400 pages of material that we cover during the seminar. We also have a special hands-on mobile development workshop on December 6th, where we'll teach you how to use Red Studio XE5 to develop iOS and Android applications. My latest book is Delphi in Depth, Client Datasets, and you can find out more about that book at www.jensendatasystems.com/cdsbook. Next, we have the questions and answers session for this seminar. Once again, thank you very much for joining me.
We have on the line Cary, Jensen, and Dmitry.
Hello, everyone.
Hello, everybody.
And there he is, Dmitry from over in Russia. And it's great to have Dmitry, who created AnyDAC and is the chief of FireDAC. So Dmitry and Cary have answered a bunch of questions. I've stuck in some answers, and so has Tim. So let's go through some of those, and then if there's other ones as we scroll down, we'll get there. See, Tadeusz asked about accessing database by IP address, and Dmitry answered that yes, you can use the IP address on some databases with FireDAC. In most cases, you can specify IP address. I know for Oracle, for example, I specify the database name, and then it goes through the Oracle system to get to the actual path that's in the configuration file, TNS names. He also asked about using DataSnap TCP/IP client, and wants to know if he can exchange the dbExpress with FireDAC components in his database access. And Dmitry answered, you'll need to replace the dbExpress components with the corresponding FireDAC components. Also set resource options.datasnap compatibility to true.
Yes, exactly. So everything is compatible, and all you will need is just to replace ADO components with FireDAC corresponding components. And moreover, I think in close future, we will prepare automatic ADO to FireDAC migration script, so migration will be semi-automatic.
And Peter was asking about more FireDAC integration in the IDE, and Dmitry answered that that's on the roadmap to the Database Explorer, the Query Builder, and all the integration things, as well as additional component editors like a memtable editor, for example. So Dmitry's definitely working on more integrations inside the IDE with the IDE team.
And currently,
go ahead.
Currently, there is the FireDAC query editor on. I demonstrated a number of times in the presentation where just right-click on the FD query component, and there's a query editor that comes up, and you can. Now, it doesn't have. It's not the same, but as some of the query editors, like in the Database Manager or Database Explorer, where you can drag and drop tables, but that's, I don't know, I've never been a fan of query editors where it shows me tables and I'm dragging and dropping them onto a query so that it is basically building out my statements and then showing me fields that I can drag. I mean, we type for a living. I don't. That drag and drop doesn't do anything for me, but I guess some people use it.
Yep, and there were questions about the source code and the white paper, and all of that will be linked off the Rad in Action FireDAC webinar page. You'll also, everyone who's on this webinar will get an email with additional links to all the information. So you'll get everything that Cary talked about. And if you can't find something, you can send Cary an email. His email address is there. You can send me an email, david@embarcadero.com, to get all the stuff you need. There's also a lot of information that Cary links to in the doc wiki for FireDAC. So lots of information there. Let's see. There's a question here from Igor about cached updates. Cary, looks like you and Dmitry also answered the question. Let's see. You should surround applying updates. You both were saying into an apply update, you can do a commit rollback, right?
Exactly. You can tell if you're able to apply all your updates or not, and you basically get to decide how you do this. There's actually two different ways that updates can be applied. You can either use the decentralized or the centralized method. In the decentralized method, you're calling apply updates on individual FireDAC datasets. And in my, let me see, in my example of my cached updates example, the call to apply updates is in fact wrapped in a transaction. So begin a transaction, call apply updates. If the updates are applied successfully, the transaction is committed. If not, it's rolled back. So that's actually in the source code there. In the centralized model, you have multiple data sets that are hooked up to a common FireDAC object, and Dmitry, the name of that object, it's the schema adapter. Is that right? The FireDAC schema adapter?
Yes, exactly.
Okay, and when you hook these up to the FireDAC schema adapter, the FireDAC schema adapter is the component that's controlling the cache, and it does it for all of the hooked up FireDAC data sets, so that you call applied updates on that FireDAC schema adapter. And again, you would, if you want transactions there, you would wrap that call to apply updates with a transaction.
And also want to add that with centralized cached updates, you can actually have data sets coming from different databases. So you can work, let's say, then you will need to start several transactions for all connections.
Interesting, yeah.
And also in the client data set sort of briefcase model, there's an event handler called on reconciliation error. If you get any reconciliations and apply updates, you can choose what you want to do. You could abort the update. You can skip the one that we give you the information about the error that takes place. You could skip and keep applying other updates. On the provider interface, you can also say on error, and you can handle things on the provider side if you want to.
It's actually a little bit, it's actually significantly easier with FireDAC. Specifically, the FireDAC datasets and the FireDAC schema adapter have an on-update error event handler. Plus, when errors occur during your call to apply updates, the records in cache are attached with two things. One is a flag that indicates that that particular error is or that particular record has an error, and then you can use the filter changes property of the data set to say, show me all the records in cache that had errors. Furthermore, an exception is attached to that record as well. So you can filter to just the records in the FireDAC dataset that has the errors, and then you can inspect that exception. So it's actually a lot easier to deal with, or you can use the on-update error. But that's in FireDAC, that's actually attached to the dataset itself, or to the, I believe the FireDAC schema adapter has both that on-update error as well as the on-update record, where you can write your own event handler to take control from FireDAC and say, okay, I am going to write this data down there. And again, like you do with the client dataset provider interface, you're given sufficient information to know exactly what's going on, what kind of update are you doing, what changes were made to that record if it was a modified record, and then you could do a potentially very exotic update. And all of these features concerning cached updates and FireDAC were covered more or less in my Code Rage talk. I certainly, cached updates and many of these FireDAC topics that were covered in this webinar are very, very rich, and so you could write an entire book chapter about almost every single one of them. But you can look to that Code Rage replay to get more information about that.
And John F. was saying he was having an issue with his Oracle his Oracle environment, and I've tried Oracle on our end here and haven't had any problems with FireDAC. But Dmitry said, feel free to send an email, and he posted his email address with the specific description, John F., of the Oracle problem. So take care of that. We'll track it down. John M. was asking, when using ArrayDML, do you have to know exactly how many changes you are making ahead of time? And Dimitri answered, you should know the exact number of items in the array. If you have a set of items of unknown size, then you can split your big job into several sub-jobs of known size.
Yes, so for example, you have a very large array of data, and you can split it into several sub-arrays of known size and process all the big array by several sub-arrays, kind of that.
And then Al was asking about FireDAC and a database called OrientDB, which has SQL query-based language. And Dimitri replied, you can always use the FireDAC ODBC bridge driver to get to any other database that's not directly supported if you have an ODBC connection. Let's see. Alf asked, with the monitor, can I also insert my own messages in the monitor stream? And Dimitri answered, yes, you can. Somebody asked who was speaking, and originally it was Cary Jensen. Even though it said David I was speaking, I was playing the session that Cary recorded, and since I was the organizer, it said I was talking. But Cary and Dimitri also talking now here live in the Q&A. Alf asked about speed comparisons, FireDAC versus dbExpress, and Dimitri pointed to a URL about data access performance. So the URL is there for everyone. Is it better to use FireDAC memtable over T-client dataset? I guess Dimitri and Cary both can talk about that, because Cary's got a book on client dataset, and Dimitri created FireDAC. So anything to add? I mean, Dimitri answered yes, FireDAC memtable is fast and more flexible. Anything else to add, you guys?
Well, I would want to say that, yes, the FireDAC memtable is an incredible component. I don't have nearly the depth of experience yet with that component, and over the next couple months, I'm really going to explore it. You may have noticed in this presentation, I covered it just tangentially. It is a very fast component. It has few of the limitations that the client dataset has, and I really look forward to, as we move forward with this, becoming very comfortable with that component, because the times I've worked with it, I've been very, very impressed, and it's unlikely that we're going to see much further development in the client data set, right? Actually, I would say probably for the last 10 years, anything done to it has been just tweaking it a bit, bug fixes. There's been no new features. So, but Dimitri, I'd like to turn it over to you so you could sing some of the praises of the memtable, which, because it's clearly a superior memory table. Am I still online?
You're still online.
Oh, okay. I don't know. Do we lose Dimitri?
Typing a question.
Oh, okay. Still, the client data set has a tremendous amount of utility to the currently. In fact, one reason why I built when I built my DataSnap server, I used the DBX interface with iApp server fast. Let's see, it used to be called iApp server interface for the DataSnap module, but it is now got some longer name, iApp fast server or something like that. And it's extremely convenient because you can take an entire client data set down to the client, make changes to the client data set, and then call apply updates, and it actually pushes the changelog back to the DataSnap server so that it can apply the changes. I suspect, and in fact, Marco Cantu in his DataSnap presentation at Code Rage 8 alluded to future enhancements to DataSnap, and I think we're going to see much more of that kind of very easy to manage data that can be edited on the DataSnap client, and then the responsibility of applying the updates to the DataSnap server without having to write a whole lot of server methods. And I'm really looking forward to it. I suspect that we're going to see more of that in the FireDAC memtable, though I'm not familiar enough with it right now to say for sure, but I don't think it can be used directly in that same form as the client data set was originally designed for the data snap. Opening the client data set and then calling apply updates in the client data set in the client.
And I forget who it was, because, oh, here it was. Alf asked about 64-bit MySQL directly, and you can use FireDAC native to get to the native MySQL driver. FireDAC works with 32-bit, 64-bit on Windows, and FireDAC works across all the other platforms, OS 10, Android, and iOS. So you have all the possibilities to connect.
One of the challenges I would see, of course, if you decide that you're going 64-bit for your driver, and one of the questions is, why do you need that? Is there a benefit to you as a developer for that? Because that means that your application itself, your Red Studio application, is going to have to be a 64-bit application. And furthermore, you're not, now correct me if I'm wrong, but you're not going to be able to use that 64-bit driver in RAD Studio as a design time connection to your database. So you lose one of those really nice capabilities, which is to be able to view your data in the designer at design time, because RAD Studio itself is a 32-bit application and it can't use a 64-bit driver at design time.
Yeah, there was a question here about the FireDAC demos. The FireDAC demos are included with the RAD Studio demos in the samples folder. So if you're not finding them, just send us an email. There was a question from Laura about if I want to clone cursor to memtable, a query, do I need to fetch all? And Dimitri answered, yes, you should do that. You want to get in your memtable all records. Otherwise, you will get only the fetch records for that moment in time when you clone the cursor.
David, I want to return back to that 64-bit, was it MySQL that they were asking about? I want to point out that you can touch a 64-bit database server from a 32-bit application. That's not an issue. So if you want to be running your database servers 64 bits so that you have access to all the RAM that you get in that address space, that's perfectly fine. There's 32-bit drivers that will talk to your 64-bit server.
Yeah, it just looks like a remote database in a separate process.
But if you do,
it's on a separate machine or kernel.
Yes, okay. Precisely. And then also, if you decide that you're going to use in your application the 64-bit driver, that means you can only deploy 64-bit versions of your application. You're not going to have a 32-bit version, or you're going to have two versions, one with a 32-bit Red Studio application that's talking to the 32-bit driver, and a 64-bit Red Studio application that's talking to the 64-bit driver. I don't see a real benefit in the application side for the 64-bit compilation in this particular scenario, though I totally understand the advantage of the 64-bit database.
Just want to add that normally the 64 bits database applications, they're not just the database applications. So very normally some over requirements for 64 bits. And because you cannot split application, let's say one part is 32 bits and another part is 64 bits. So yeah, you should use then 64 bits database access. But normally, yes, I absolutely agree with Cary that normally there is no reason to compile some classical database application into 64 bits executable.
What software were you using to use the tablet screen, Cary?
Okay, I was using...
Of some kind?
Yeah, I was using VM Lite, what's that called?
VNC Lite?
VNC Lite on the tablet, and then on I actually used the real VNC viewer from my virtual machine. So I've got kind of an unusual development environment. I do all of my development in virtual machines, and I've blogged about that in the past, what huge advantage I gained from doing that. However, there were several different mechanisms I used. Let me see if, I don't have the virtual machine running right now, so I can't tell you real quickly, but there is also a utility that you can get from from Google Play that will make your connection to the VNC Lite server on your tablet, and you can then use a browser. You can use Java to connect over. That particular example, I was using the VNC. And you know what? I tell you what, I'm going to answer that again if we're still on once I get my virtual machine running, because it was a very nice solution, and there's multiple solutions for doing that. Although it's more critical for people like me and Marco and you, David, and Jim, who are getting up and actually showing people from their PC what's going on in the tablet. You don't need that at all if you're just simply developing for the tablet. It's only really essential when you're demonstrating from your PC what the tablet is looking like. And it's not hard to do. It's just you have to do a little research, and it takes setup, and you have to have the Android debug USB driver installed, and so many of the talks at Code Rage and other recordings that Embarcadero has posted do talk about the steps you need to go through to that last set of steps in order to get your tablet attached through USB, which just makes it extremely convenient to build your applications. But even that isn't essential. You can, without getting all of that working, you can compile your Android packages from Rad Studio. You can write them to typically to a micro SD card, and then you take that card out of your PC and you slip it into your to your tablet, and then you can simply run the package from there and it'll install it. Of course, you also have to have told the tablet that you'll allow these allow applications from unknown sources to install themselves. But that again is covered by many of the Embarcadero videos.
There, Dimitri and Cary, maybe this is more for Dimitri, I'm not sure. There's been several questions about if I have, or how can I access from a mobile application directly using FireDAC to a SQL database. I know we tell people you can access SQLite and you can access Interbase to Go, Interbase Lite locally, and you can use DataSnap or some mechanism to talk to remote databases. Are there possibilities to connect from a mobile app directly to a SQL database on a machine somewhere?
I'd like to address that first to say that's probably not a good idea. The number one thing you're going to absolutely need is for either iOS or Android, you'd need the local driver for that database. During some of my research, I stumbled across some information from Oracle that they may have such a thing, but typically what you're doing from your Android device or your iOS device, you're either using a local database on the device, which again is, whether you'd want to do that or not is a question. And then of course you could use just the FireDAC mem table and use your save to file and load from file. But typically what you're going to want to do is from your mobile devices talk to a middle tier. So this is why DataSnap is such an essential and beautiful solution. You can create your DataSnap server. It could be a DataSnap REST server, and you could communicate using just simply using REST calls to your DataSnap server. And in Rad Studio XE5, there's this beautiful REST client set of components that allow you to avoid using, well, what I did in my earlier applications is I used the Internet Direct or INDI components to make just straight on HTTP calls to my RESTful server to retrieve and post back data. But now with these new REST client components, it's very, very easy to set up the request and response from the mobile application, and it's kind of a recommended way to go. And then if you need local persistence, if that data is moved into FireDAC components, and you simply have the save to file and load from file that you could supplement that with.
Anything to add, Dimitri, about direct connect to databases besides the local databases from a FireDAC mobile client?
Yeah, we are considering to implement, let's say, wire protocol drivers for MySQL server, and technically speaking, okay, in theory it's possible actually to work with any database directly if this database has sources, so we are able to recompile them for a target platform like iOS. For example, in Cary, again, in Cary, it's possible to talk directly with SQL Server using free TDS and Unix or DBC products. But again, it's a work in progress, so
we're beyond our time, but I just want to get to a couple. Alf asked a question, looks like twice, about Oracle and BCD. It says, do I need to do something with FireDAC in order to send integers to the database server instead of sending BCD, which crashes an Oracle client? I'm not sure. He was talking about dbExpress, and Oracle seemed to set a variable about accepting BCD instead of integer in function parameters. I guess, I don't know if that's calling store procedures. Not sure if there's anything special about FireDAC and sending values over to a backend database server of different types.
Not sure what is actually the question.
The question, yeah, it's by Alf Christofferson. He's asking.
No, actually, with FireDAC we can work with integers without the problems, at least with Oracle client. So I'm doing that quite often without any problems.
Okay. Al asked a question towards the end here. I used refine.exe to convert BDE to FireDAC. Since session is no longer supported, let's see, it's no more supported in FireDAC, it is marked as removed. There's a little sample code there. There's something about auto session name property being not found. Any idea how to fix?
Okay, let's say BDE to FireDAC migration script was just finished, and I tested it with several comparably simple applications. So what I see, it means I will just add more capabilities to this migration script to resolve this issue. So yeah.
David, I can readdress the question about viewing the Android device over USB from Windows.
Yeah,
so yes, as we had discussed, VM Lite VNC Server is what I have running on the Android tablet. I bought it from the Play Store. It was $7.99 US.
Yep.
When I installed it on the tablet, well, when I first started using it, I was pointed to the VM Lite Android app controller for Windows, which was a free download. And once you connect, and you do that from the Windows, you actually launch the VM Lite VNC server on the Android device. And then once you make a USB connection, it shows you a couple ports that you could use on localhost from your Windows application to talk to that Android device. One is you could use it for a browser, or you could use any VNC client, any VNC viewer, and then there's another port that you can use to communicate. So the VNC viewer I used was the real VNC viewer.
There was one, and Rafael left. He said, can we define our own macro functions in design time, which will then be pre-processed by FireDAC engine, and the result be inserted to dynamically build the query?
No, it's actually not possible because the set of macro functions is predefined, and you cannot extend the set of macro functions. But it's actually a good idea. Why not? We will consider to change the current approach.
Okay, I think that's most of it. There was a question, Tadeusz is gone. He talked about, he wanted to know about professional versus the FireDAC client server pack, and I'll just answer it, that if you're talking to a local interbase or Firebird database on your local machine, then professional works fine for you and you can connect to it. If the database is remote, then the client server pack is there for you. And again, for John F., The white paper, the example code, the replay video will all be linked off of the same webinar landing page sometime next week. The register now will change to an on-demand, and the other links will appear on that page. And again, everyone, all of you that attended and those that maybe dropped out or couldn't attend, they'll get emails next week pointing to all of that information as well. Cary or Dimitri, any last words before we stop this one? And I've recorded all of the live Q&A, and everyone can save the Q&A log. There's a save questions log under the file, or maybe that's just for me as an organizer. I'm not sure.
Well, I want to thank Dimitri in person. We have never talked. We have communicated via email many times. Dimitri, thank you very, very much for FireDAC and any DAC. It's brilliant. It's beautifully designed. I am very, very impressed and very excited to be using it. And I want to thank you personally also for the help you've given me to understand this.
You're welcome, Cary. I'm happy to help. Actually, I'm happy to work on this product and to make it better if it's possible. But for that, of course, I will need some feedbacks and actually the questions from all the attendees. And yeah, that was actually interesting to listen for me to your presentation, Cary. So thank you for your presentation.
I put the code samples as they exist now out on the site on my own website. It's www.jensendatasystems.com/radinAction FireDAC. No space, of course, no spaces, but no dash. Is just radinAction FireDAC, all one word, and you can get that code now. But you want to come back to that code because, as I mentioned at the end of the presentation, I did not go to the appropriate. Well, how should I put this? I didn't build the mobile interfaces the way I wanted to. I built them kind of in a super hurry, so I just dropped down a DB grid, but that's not, or not a DB grid, but a FireMonkey grid, and that's not what you do in a mobile application at all. So what I'm doing now that I've got all my other obligations out of the way is I'm going back for both the SQLite example and the DataSnap client example for mobile, and I'm redoing them with the proper interface for those for that target platform. And so that will be available. That's not available now, but that will be available next week when the replay and the white paper are all available online.
And if you want, you can post that URL that you mentioned into just one of the questions as an answer, even if it's one you already answered.
Yeah, it's up there a couple. I've got it a couple times. Let me see if is there? Can we just let's see here? I guess do I answer a question, or do I post a question? Let's see.
No, you can't post questions. Here it is. It's capital RAD. Okay.
Well, and it's not a Linux server, so it's not even it's not case sensitive. In fact, when I was testing out and typing it into a browser, I had my cap locks key on, so I had it exactly opposite case from that, and I still got to the site.
Let's see, rad and fired. Because I thought I typed it in and I got a not found, but that's just me. I'm sure typing.
So yeah, jensendatasystems.com/rad, RADINACTION FIREDAC. Yeah, it should be there.
Yeah, I put that in. jensendatasystems.com/radinAction FireDAC, and it says not found. But maybe it's me. Oh, you know, I got it. Sorry, never mind. I'm in Google search. It's not going to find it. Go to your URL bar, David. That's ridiculous. Okay.
I hear someone yelling from here. I hear someone yelling from the other room. It's there. It's there. They're looking at it online from their machine.
Just stupid browser guy. There was a question here about DB2, and we support IBM DB2. There was a question about AS400, and there is the native DB2 driver. I'm not sure about connecting to DB2 for AS400. There's always ODBC.
Yeah, there's ODBC, and I don't know the answer to that one either. There was also questions about NextDB, and what of course, it would if we had if we had Dimitri online, he may know. And David, I don't know if you know if Embarcadero has said anything about that database in the
We haven't said
roadmap.
anything. We haven't said anything specific. We've been sending the feedback to Dimitri and the team and product management about other databases to support. So, well, you know, we'll put them on the list and see what can be done. There's always the case that some of our partners may build a FireDAC driver or a connection setup as well. So we'll spread the word in all ways. ODBC on Windows, ultimately, if there's a connection there, you can absolutely use that with FireDAC without any trouble. Questions about 64-bit, and again, 64-bit, FireDAC has 32 and 64-bit Windows support, and if you want to talk to a local database in a 64-bit in the same process space, great. If it's a server, then the server's remote somewhere or local and running in its own process space, so use what 32 or 64-bit, doesn't matter. Yeah. There was a question Gary was asking about, does FireDAC take care of blocking SQL injection?
And yes, and SQL injection, for those of you who are not familiar with it, it's a very important hack to be aware of. If you ever assemble your SQL statements dynamic at runtime by taking input from the user, you have to be aware that if a user is aware of the SQL injection hack, they could actually enter in, for instance, a semicolon to terminate the end of the SQL statement in their where clause, possibly a comment line indicator to say don't ignore the rest of the where clause, and then have a delete table statement or something very evil like that. So this is not something that FireDAC is responsible for. Us as database developers, we can avoid that SQL hack completely by always using parameterized queries and parameterized stored procedures. Because if someone did type in something like the delete table customers or something like that, if it was assigned to a parameter, the SQL engine recognizes that you're actually you're searching for, or you're comparing something that includes delete table customers, and not interpreting it as part of the SQL statement itself. So SQL injection is avoided by using parameterized queries and parameterized stored procedure calls when you're obtaining the information that is used in the where predicates from some source that you don't control, like user input.
There was a question here about Active Query Builder, which is a tool, ActiveQueryBuilder.com. There's a VCL version, and it basically is a component for creating SQL queries and doing things visually. I think you could take whatever query you build with Active Query Builder for VCL and pipe it into a FireDAC query and then fire it off from there. So I don't think it goes in. It doesn't look like it goes directly to dbExpress or directly to something else. It looks like it gives you a result, and you can set it to a data set.
Right. If it's using data sets, then it can use any data set. And as I made the point early in the presentation, the FireDAC is not only a T data set to send in, it's an exceptional T data set to send in. And consequently, if active query objects or whatever that tool was, it was a pretty early question here. I don't.
It's Active Query Builder.
Active Query Builder. If it uses RAD Studio T datasets, then it's going to be able to use FireDAC.
Well, I'm just looking. I'm trying to look really quick, but everybody else can look at. Here's the product environment. Let me. I'll post that link in the answers to that question as well. The sample code, yes, we'll have all this. Cary will put up the sample code, and he already put the link there. There was an additional question about S400. Roger, we'll pass that along to Dimitri if there's something specific for FireDAC and whether he has plans for AS400 version of DB2 versus DB2 running on whatever it is, on Windows, Linux. I think we test against on all our drivers, we test against the Linux and Windows version as opposed to the mainframe version of DB2. Does cloning a data set always involve fetching all records, for example, cloning ADO data set?
Well, we're talking about now the FDMEM table, I'm assuming, and the FDMEM table is, it does. I wish I could say more about the FDMEM table. I have not had the luxury of time to investigate it as thoroughly as I will eventually investigate it, and I definitely believe that you can limit the number of records that you load into it. Another thing to think about is that you can use the local SQL and use a limit clause to say I want to extract some records from any data set using local SQL, but I want to limit it to this specific number of records. Or client data set, of course, has a packet records property where you can say I only want to get at least this many records initially, and then you call get next packet in order to retrieve additional records. But I suspect the answer is yes.
And then there's a couple questions about transaction processing. Cary, if you want to just reiterate something you posted about transactions.
Yes, transactions are supported by the FD connection component, so you can start a transaction or begin a transaction, and once you begin a transaction, of course, you've got to have structured code with a try finally, or excuse me, a try except clause, so that after you perform your series of operations that you want to treat atomically, that you commit the transaction, and then in your accept clause you're going to roll back that transaction because something has apparently gone wrong. Likewise, if you're using cached updates and you call apply updates, you may want to roll back that transaction if not all of the updates could be successfully applied. And the cached updates example that I demonstrated has code that shows that approach. So yes, you have, and the most important thing about FireDAC is it has because of its native drivers that are intimately familiar with the specific databases that they are designed for, that you can have simultaneous multiple transactions or nested transactions depending on the database. So there is excellent transaction support through FireDAC.
Yep.
But you are, again, this is something you are going to be the one to decide if you need transactions or not, so you will explicitly code your updates. Speaking of transactions too, I made a big deal about the fact that just out of the box and with your simple configuration that as you changed and inserted and deleted records, they were posted on a record-by-record basis. Quite often we want to do a transaction so that we have multiple, let's say, batched updates, and in that case you used cached updates. You'd enter the cached updates mode, either in its centralized mode or its decentralized mode, and I'll say a little bit more about that in a second. And then you apply your updates, and then you would commit the updates or roll back the transaction depending on what happens. The cached updates has two distinct modes. One's called centralized and one's called decentralized. Decentralized cached updates has you placing individual FireDAC data sets into a cached updates mode and then applying it on a data set by data set basis. If you have multiple data sets that you want to apply as a group, then you use an FD schema table. I'm sorry, an FD schema adapter component in FireDAC, and you let it take care of the cached updates. And you do that by assigning each of your FireDAC data sets to the FD schema adapter component that you've placed into your data module, and then you enter the cached updates mode on the update schema adapter, and you apply updates through the update schema adapter. And that's particularly useful when you have a situation like a master detail relationship where you want to treat all of those, the master and the detail updates, atomically. So in that case, you would wrap a transaction around the applying of updates to the FD schema adapter component.
Okie dokie. Getting ahead of myself here. Let me go back again. Okay. XSDB. Okay, we were there. Gloria of Delphi. Marco's working on a Delphi programming language book based on his Pascal handbook, but with all the new language extensions for mobile, so stay tuned for that. Several people are wondering, is FireDAC the future? And I answered, absolutely is the future. We're spending all of our effort on it. BDE will eventually go away, as Cary mentioned. dbExpress is still there and will stay for some time for people that are using it. But FireDAC, and that's why there's all these migration utilities and articles and videos to show you how to move to FireDAC. FireDAC is the multi-device future. Absolutely.
And certainly some of the things that have been alluded to during Code Rage, for instance, Marco Cantu mentioned. He wasn't really specific, but he kind of talked about the future of DataSnap clients and FireDAC, and I have to say that got me very, very excited, because the DataSnap itself, that architecture, is really an important architecture, and Delphi was so early in supplying developers with a manageable mechanism for building distributed applications like that. The thought of having these really powerful FireDAC components in our cross-platform clients and being able to communicate to the various DataSnap servers and doing so in ways that are even more powerful than we have now make the future of FireDAC very, very exciting.
Several people have been asking about performance. How is FireDAC compared to other things, dbExpress or?
It's a real good question, and all I can say is FireDAC is very high performance. In fact, now let's make it clear, Dimitri is a big fan of FireDAC. You know, he built it, but when he was doing the technical review of my paper, he specifically said, look, you know, one reason why people may want to migrate an existing data access framework to FireDAC alone is that you're going to get a performance improvement. It's just really streamlined. You have a great deal of there's a lot you can do property-wise to configure the access. It's amazing. Once you start digging into it, you see so much surfaced about how it can work. And there was a question that's saying, if I've got a DataSnap server, if I put FireDAC on there, will I see a performance improvement? Well, that's hard to say there. You will have a performance improvement on the server, but the network communications is the big variable there. So you might, from your clients, you might not see something truly measurable. And also, of course, the efficiency of your actual queries that you're executing from your DataSnap server. But if you look at query by query, you're probably going to get an improvement in performance. In some cases, slight, and in some cases, very significant. So yes, it is a high performance data access mechanism. There's no doubt about that. I see a question here that I'd like to address because I think it's an awfully good one. And I had mentioned in the presentation that the FD query was the preferred component. And the reason why is FD table, while it's really great if you just need to create a fast and dirty application, it has some special characteristics that give it a lot of performance, but that may cause you to run into to need to do some tweaking of the properties. Specifically, FD table by default, when all else is equal, uses a FireDAC mechanism called live data window. And with live data window, what FireDAC does is it loads into memory only twice as many records as the there's one of the fetching settings is the number of rows you want to get, and of course if you have a grid or something that requires more than those rows you measured, it's going to get the records you need. But the live data window is like a sliding window. So what happens is the data comes back very, very fast, and it really minimizes the footprint in memory because you have just, say, like 50 or 100 records in memory at any one time. The problem, though, is that you can get kind of a little bit out of sync because it keeps on, paging these records in and out of memory. The FireDAC documentations talks about the kind of possible problems you can run into, but it does have the benefit, FD table does have the benefit of having a very small footprint memory-wise, as opposed to a FD query, which is going to bring in lots and lots of records and have a much bigger impact on memory. However, you're not going to run into issues. Things like key violations are possible with FD table, but if you run into that type of issue, there's very specific things you can do that are well documented that will prevent that. But FD table uses live data window. Now, one of the side effects of live data window is you cannot open an FD table and then enter cached updates mode. You have to be in cached updates mode before you open the FD table, because then it will not use live data window, because that would end up preventing the FD table from eventually applying the records properly down to the underlying database.
There was one question, I have to find it now. It was about someone had used, they had used FireDAC for exe4. They used ADDFM changer to migrate old BDE code as their new version for exe5. I know there's utilities, but maybe you know, Cary.
I was actually reading another question. I'm sorry about that. About moving a BDE.
This was from Mary. They had used ADDFM changer to migrate old BDE code as their new version for exe5.
Dimitri is getting very close on having the migration scripts for BDE to FireDAC available. I don't know what that all is going to entail. I will say that the FireDAC Explorer and I believe also the FireDAC Administrator, those two components will do importations of BDE aliases, but that's not the same thing. I looked at that and I thought, no, I don't care about importing the aliases. That's not the issue in migrating a BDE application to FireDAC. But it actually, it's just a matter of replacing your T tables and T queries with FD queries, your T stored procs with FD stored procs, and then defining how you're going to access the data, such as I showed with the ODBC to Paradox connection.
I know there's also, I'm just saying, sending a message to Mary that about the scripts, but there's also utility in exe5 for renaming all your AD XXX components to oh, sorry, I better put FD, not DF, your FD XXX components in forms and elsewhere. So there's,
and I discussed that in the white paper, and it works pretty well. Sometimes it works 100%, but then it's actually really what it is it's a template for you to make migrations. So it uses a utility called Refind, which uses the Perl regular expression engine to do substitution in your units, DFM files, and other associated project files. Right now, though, for instance, if you have any ADO components, the ADO components are going to be changed to FDO. So if you are comfortable with regular expressions, you can go into the scripts and accommodate that. Whether the BDE conversion is going to be something like that, I'm not entirely sure.
Okay. I think you already answered this, but maybe I was typing the answer to something else. It's always that question about FD mem table versus client data set, and when are you going to write your FD book?
Oh, yes. As soon as I can figure out how to just avoid having to go to sleep, I'll get right on it.
Well, the white paper is a good start. That's a really good.
Yeah, the white paper is a start, and it's and I'm just so impressed with FireDAC. We here at Jensen Data Systems, we've had a lot of discussions about this. I really want to write a FireDAC book, but I need to be able to do it in a reasonable period of time. For instance, some time in the first half of next year. I want to do it, and I'd say there's a pretty good chance that I will make the time to do that, because I think it is terribly important to have additional material to refer to, and then of course I'll tell you, it's on a selfish level, writing a book is a great way to really understand something. You can't really you learn a whole lot more about a topic when you have to explain it and pre-digest it in writing. So it would be a very beneficial thing for me as well. And that obviously would get me well into the FD mem table, which is a component that I'm just really interested in exploring much more deeply.
Yep. I usually build a lot of examples first and then start trying to describe what I wrote. But I'm sure there's many ways to document everything and to end up with a book. I just I don't have the time, so I just put up more videos and more webinars, but and blog posts. Yeah, someday maybe. Data snap application convert to FireDAC on the server side. Yeah, you can do that, and this is Wayne. You'll get the performance side on the data snap servers, talking to the remote databases. The only way, in a sense, to have improved performance on the client side is to do your queries well and your where clauses well, so you're only bringing back the data to the client, right, that you need. You can use FDMM table on a client. Keep using client data set on a data snap client.
That's the. Are we talking about the data snap client?
It's about data snap. They want to convert to FireDAC on the server side. The question
exactly. So that's what I did. My data snap server uses FireDAC, but it still uses the more traditional dbEx data set provider and client data set. And the reason why is that that interface using SQL connection and on the client and a data snap or a data set provider on an IAP server interface supporting data module on the data snap server is the simplest way to be able to provide data to the client application, let the client application make changes, and then send the change cache back up to the server for application to the database. I don't see that. Now, this again, it may be there, but I don't believe that the FireDAC mem table does that. It has an internal structure that's slightly different in terms of how it stores its data. So I think it's great to use an FDMM table, and even the new exposing server-side functions that return data sets, but I don't believe you get the change cache there either. It could be that I just haven't seen it yet, but most of the client examples that I've seen that don't use the client data set on the client and data snap or data set provider on the server, they're pretty much read-only, or if they're reading and writing, they're writing by calling server-side methods and passing parameters rather than simply saying, oh, here's my changelog for my data set. I expect, fully expect, we're going to see that type of thing in FireDAC's future in the data snap client. And that's what gets me very, very excited. Again, Marco alluded to that potential in the future. So it's going to be really exciting when that comes up. But in the meantime, I just found that I can do this thing in the traditional data snap way by using client data sets on my data snap client.
Yeah, and Marco did talk about some of the future plans for data snap underpinnings and performance improvements both on the server-side, client-side. So stay tuned for that. There's a lot of work going on for the next generation and generations to come of data snap, separate from FireDAC's access of data wherever it's being used across your application architecture.
That's right, but FireDAC, with FireDAC being the go-to data access mechanism for the future for RAD Studio, we're going to see that FireDAC. We're going to see FireDAC being, I believe. I mean, this is my crystal ball prediction, but I think we're going to see FireDAC really, really become data snap friendly in a very tight way, and it's going to just give us a great deal of light bandwidth requiring clients, especially for the distributed applications that we're going to continue to build as we go forward into a more mobile future.
Yeah, somebody was asking about dbGo, but there's nothing aware of about FireDAC to dbGo connection. There's FireDAC to ODBC and FireDAC to dbExpress.
Yeah, and Microsoft has really, really de-emphasized OLEDB providers. It's a COM technology, but then again, Microsoft is they have an attention span problem at Microsoft, but ODBC is definitely the preferred mechanism over OLEDB providers if you see about how Microsoft is emphasizing connectivity. I'm really surprised by that, but I think that it's very that the comms very Windows-centric view of the world and the overhead associated with it has led them to that conclusion. By the way, you might get if you hear an explosion from my side, it's lightning. It's just started raining real hard again, and I could hear some thunder off in the distance. But we had some real close strikes within the last hour.
Yeah, no. If we had video cameras, we could stick the camera out the window and let us see.
Really?
Again, there were a few questions about things like other databases, NoSQL databases. Jim is putting his vote in for MongoDB. We're taking a look at the whole NoSQL database support and how we can do it. We do some of that today in Azure and Amazon with their tables, queues, and blobs. Oh, there was a question Keith was asking. You mentioned FD query was preferred over FD tables. What are the issues with using FD table components?
Well, yeah, that was where I went into the details about live data window.
Yeah.
Basically, that's it. But the beautiful thing is that by default, even with the BDE, you had to say that you wanted to request a live result set in a T-query, and you don't have to do that with FireDAC. It's even remarkable. FireDAC queries may include joins, and in some cases, FireDAC can even figure out how to write that data back down to the underlying database. So my feeling is just write the FD query, and maybe the live data window is going to buy you a lot of performance that you want, and especially if it's read-only, it's not a problem.
Oh, I heard that.
Did you hear that?
Oh, yeah, I heard that. Yeah.
I guess my noise-canceling microphone or isolating microphone may have not have bit that up, but we just got a real close lightning strike.
Let's see, Alistair saying Delphi was ahead when the briefcase features introduced. Happy with cache store updates to a server, Blue. Since I said, yep, thank you very much. Yep, we were very early with the whole briefcase model with client data set going back to Delphi 3. Does FireDAC have encryption built in? FireDAC doesn't have encryption specifically built in. That's handled at the database. We do have encryption with the JSON packets for DataSnap, and our interface has encryption at the database, table, and column level. So there is support for working with encrypted files.
There were a number of questions asking if I had examples in VCL and FireMonkey. Well, about half of those examples were FireMonkey examples, and about half of the examples were VCL. The ones that I created on the fly were VCL applications, just that they're really super simple. Actually, to be honest with you, FireMonkey applications are very, very easy to wire out using visual live bindings, so I could have easily done that as well. The most important thing is that both the bind source DB in visual live bindings and the data where controls in VCL all use T datasets. And as I explained at the beginning, FireDAC datasets are exceptionally good examples of the T dataset interface. So anything that you can do with a traditional dataset, such as a T table, an ADO dataset, a SQL dataset, you can do with FireDAC. There was also some questions regarding replacing dbExpress with FireDAC. Certainly, your user interface becomes a whole lot more simple if you can use FireDAC without the necessity of having an in-memory dataset like the client dataset sitting out there and caching the data, and then you have to make sure that you call apply updates, and just all the responsibility that comes with building the more complicated dbExpress interface. But you can replace your dbExpress components with FireDAC components if you have used that caching architecture where you use dataset providers to pull unidirectional read-only datasets into client dataset. You can actually use FireDAC like that if you want. In fact, if you're really trying to squeeze performance out of your data acquisition and you are very comfortable with that disconnected model of the dbExpress supports, you can implement that. You can implement that very, very easily in FireDAC. Here's a good question that I did not address in the talk, but is addressed in the white paper, which is, in which versions is FireDAC available? Well, first of all, FireDAC is available in RAD Studio, Delphi, and C++ Builder, XE5 Professional and above. The professional editions are designed for local access only. For the Enterprise, Ultimate, and Architect editions of those products, you get the full set, the superset of FireDAC components, which include the ability to connect to remote database servers, such as DB2, Oracle, Microsoft, SQL, and so forth. Now, there's another issue too. The professional edition does not come with, let me talk specifically about Delphi XE5 Professional and C++ Builder XE5 Professional. They don't come with source code. But if you bought the RAD Studio XE5 Professional, you will get source code for the associated supported components in the Professional edition. If you have the Ultimate, Enterprise, or Architect editions of any of those products, you get both the client-server components and the source code as well. In fact, FireDAC is entirely written in Delphi, and the source code includes all the units with the exception of one. There's an encryption unit that, because of export prohibitions, cannot be shipped with XE5. But otherwise, you get all of the source code for the appropriate components in the level of RAD Studio that you purchased. If you have Delphi Professional, C++ Builder Professional, or RAD Studio Professional, there is an add-on pack for client-server support, and that's called the FireDAC Client-Server Pack. And it's not terribly expensive. It's I believe in the U.S. it's $400 U.S. and it adds the source code and the client-server components to the Professional Edition. So if you've already purchased the Professional Edition and you started off being fine using local databases, but now you want to be able to deploy to a remote Oracle server or deploy with access to a remote Oracle server, you can simply go to an Embarcadero site and buy the FireDAC client-server pack and add that to it. Let's see, how much of what you talked about is only available in the XE5 version of FireDAC? In the earlier versions of FireDAC, especially the one that shipped with XE4, everything that I talked about was available. It just used different units and it had different component names. So you had an AD query instead of the FD query, and the units hadn't been restructured like they are now. It's in a more maintainable form now. So if you do have XE4 and FireDAC, you are able to do those things that I described: the local SQL, dynamic SQL, all the multi-threading is exactly the same. In fact, some of my examples, like ArrayDML, I originally wrote with the XE4 release of FireDAC, and then I converted them to use the XE5 edition.
Yeah, somebody was asking about installing on older versions, and there is a setup program for FireDAC which allows you to install FireDAC into older versions of the products. By default, the XE5 FireDAC installs in XE5, but there's an optional parameter on the setup.exe which allows you to install and build the packages for FireDAC for previous versions of Delphi.
That's true. In fact, when FireDAC was released with XE4, you could purchase the FireDAC client-server pack and install it in versions back to Delphi 2010. However, it was not specifically supported by Embarcadero for those versions. It was only supported for XE4, but you could install it and you could use it in those earlier versions. So that's a good point. There was a question early on about a gentleman wrote that he has a very large product that's still in the BDE. And is there any plans to have any tools to help with the conversion? Well, that's been being worked on, and in fact, Dimitri was the FireDAC architect, was participating in the Q&A in our early morning session this morning, and he mentioned that he's in testing with that. So this is something that we expect to see available for Rad Studio developers relatively soon. I will say it's not a tremendously complicated move. You're taking your T-tables and making and moving them over to, in my recommendation, move them to TFD queries and not stay with FD table, and just change your table name from being customer to select all from customer. Although this is also an opportunity to be able to be a little more selective and have a where clause in your select statement, so that you're really just getting the records that you're specifically interested in, instead of just opening up a cursor to the entire result set. There's a question: does the XE professional version, XE5 professional version, include a Firebird driver? And so I loaded up. I do all my development in virtual machines, and I have actually one virtual machine with Rad Studio XE5 Architect, and I have another virtual machine with Rad Studio Professional XE5. And I went over there, and yes, indeed, there was both Interbase and Firebird drivers. However, the license specifically is for local access only. So even though you can talk to Firebird, you can only talk to Firebird on the local machine by license. You would need to have the client-server pack if you wanted to go and connect to a Firebird server on another machine.
And here's the page. If they go to the FireDAC product page, it talks about the two different editions, the professional edition and what you can do as far as local database, which local databases you can talk to, and then the enterprise ultimate architect editions gives you access to remote databases. And here's that link again for everybody at the landing page. There's that URL, which I put in the Q&A log. And somebody asked the question, you have two choices. If you just want FireDAC client server, then you get the client server pack. If you want to upgrade to enterprise, you get not only FireDAC, but you get DataSnap and other things too. So there's two different prices, and you can choose which you need, the client server add-on pack or upgrade to enterprise and above in Delphi or Rad Studio. So, and again, it's all there on the FireDAC page. And if there's more that you need, just send me an email, david@embarcadero.com. And if it's still not clear about embedding or local or remote, I'll make it as clear as humanly possible.
There's a question: do you use FD connection component to connect to an embedded DB? Well, you use an FD connection component to define a temporary connection definition. And yes, you would use an FD connection. Now, you can use a higher level component, the FD manager, and define a private shareable connection definition, and then just simply assign the connection def name property of the FD connection to that defined connection. But it's all basically the same. You will use a FD connection, and you would need to use the, I'm pretty positive you'd also have to have the associated physical database driver. So the FD Phys IB driver data link component would have to be there for embedded interbase. The only time you don't need an FD connection is if you're using the load from file or save to file from the FireDAC datasets, which in that case you can treat an FD query like you treated a client dataset in a disconnected mode. And in fact, all of the FireDAC datasets support that ability to persist to a file or stream, making them handy candidates for implementing a briefcase application, or places where you know that you will have a temporary, you will temporarily have no access to your database server. You have a network where you're kind of in and out. Possibly, if you're traveling on a train, you could, when the train has, well, this would be in trains in Europe, but or in Asia where you have internet access, there are times when you'll lose your internet connection, so you might want to extract the data and then persist it locally so that you can work with it, and then when you do have the internet connection again, then you can reconnect and do things. Now, you'd be using cached updates in order to do that, but that's fully supported with FireDAC. There's a question: does my client dataset book deal much with FireDAC and SQLite? It doesn't deal with them at all, because the book was published 2 years ago. Well, now it's been 2.5 years, I think. and or 1.5 years, but FireDAC didn't exist then. There was AnyDAC, but it was a third-party product. And SQLite, no, it didn't deal with SQLite at all, because that's actually a database. And the client data set is an in-memory data set. You pump data into a client data set, but you can pump it from any database for which you have a data set, some kind of T data set in RAD Studio.
And everyone, this landing page here is where you registered. This registration button will change next week to an on-demand, and there'll be other links on this page to the white paper and all sorts of stuff. Ultimately, all the resources will show up on this Add in Action FireDAC page, which has a great picture of Cary, some videos, and everything else. So that will change next week to on-demand, and some other links will show up. So use that page and that URL. And again, everyone, thanks for being with us.